Hi, welcome back. Let's review the laws of exponents. Understanding the laws of exponents will help us and greatly benefit our strategies as we proceed to the manipulation of expressions with fractional exponents or even for the exponential equations. Let us try to talk about or review those laws of exponents as we answer or simplify items here. So for number one, we are tasked to simplify the expression with these factors. All of the factors here or terms are placed side by side, and as therefore, we are going to use here the multiplication law since all of the terms here are multiplied to each other. In the multiplication law of exponents, we just simply need to copy the base and add the exponents. But wait, when you say add the exponents, make sure that we are talking about the exponents of the same bases. In this case, let's start here with the first base here, a, and then we are going to add the exponents of all terms here with base a. So you have here a squared. Next, B, do not add the exponent of this. Here, another A. So simply add negative 3. And then another A here plus 4. This is for the exponentiations with base A. However, we also have exponentiations for base B. The first here is for this term. If again, there's no clear indication on what is the exponent of a variable or expression, or even if there's no other mention of exponent, that automatically means an expression with exponent of 1. And then plus the other expression here, exponentiation with base b, is this b cubed. So add here 3. Only add the exponents of the same bases. Lastly, c to the power of 4 plus the exponent of the remaining term here for c is again 1. And then right after this, we just simply need to simplify the exponents and we will get our result. Here, you have a to the power of 2 plus negative 3 is negative 1 plus 4 is we have here positive 3. In short, a cubed. Next, b, 1 plus 3 is 4. So b to the power of 4. And finally, c, 4 plus 1, which is 5, or c to the power of 5. This is what happens when we apply the multiplication law of exponents for item number 1. Again, do not combine the exponents here as the bases are not anymore the same. Let's proceed to number 2. For number 2, we may notice that for the it's already a fractional form of expression where the numerator has different bases, p and q. Similarly, for the denominator, p and q. In this case, we cannot use the multiplication law of exponents for the numerator nor the denominator, since the expressions with the same basis are now placed on two different uh, points, again, numerator and denominator, and they are separated by the operation of division. In short, this will undergo the division law of exponents, which tells us that we can combine these expressions with P and then the other way for Q. To do that, you have here P, copy the base, and for the exponents, subtract the exponents. And it should be the exponent of the numerator minus the exponent of the denominator. Do not interchange them because the rule states that the minuend for the process of subtraction is the exponent of the numerator, while the subtrahend should be the exponent of the denominator. That's for P. Now for Q, you may do this just to separate them. It's up to you. You have 7 minus 5. And then, therefore, you have here P, 10 minus 4 is 6. And you have here Q, and then 2. Looking at the expression, since they have different bases now, that's already your final answer. P to the power of 6 times Q squared. Moving forward to item number 3. Okay. Item number 3 now has this form. When you look at the terms inside the grouping symbol, they're actually of different bases. You have here 4, you have F and G. So you cannot apply here the multiplication law inside. Rather, we can now apply the power law of exponents. Power law tells us that if an exponentiation is all again raised to another exponent, we can just simply share or distribute the exponent to all terms, and the operation will become a multiplication of exponents. Again, it's not multiplication of terms. The terms are being raised to another expression, then we multiply exponents. If this is the case, we will get here 4, originally to the power of 1, times the exponent outside 3. Let me try to rewrite it here. Okay. And then you have here f, originally raised to the power of 5, but then to be multiplied by 3. And finally, you have g raised to g cubed rather, to be multiplied again by 3. This is what happens now, sorry, for the power law. And we just simply need to multiply the exponents. So we have 4 cubed, you have f 5 times 3, not plus, multiply. 5 times 3, 15. And you have here g 3 times 3, 9. Do you think this is really the final answer? Well, some might argue yes, because we cannot combine the expressions now because of different bases. That's correct. But I would like to emphasize that the goal here is to simplify. That would mean this constant here raised to the power of 3 or cubed should be simplified as well. And 4 cubed is 4 times 4 times 4, which is 64. And then copy the other terms, f to the power of 15, and then you have g to the power of 9. This is the result for number 3. So as you have noticed, each of the expressions here have will use different types of laws. You have here the multiplication law, division law, and the power law. As to the next, probably we also meet other forms of laws or other laws rather, and then some of it may also use the combination of the rest. Let's talk about number 4. For number 4 here, we are given with an expression with exponent of 0. And there is a what do you call this one? The law of zero exponent, which tells us that any expression, any number, any variable raised to an exponent of 0 will be always equal to 1. The proof of that is actually in your module with the use of the division law. You might want to read that for reference. So we just need to apply it here. Looking at the first term, as it is raised to 0, we can say that the whole expression for this term alone will be equal to 1. Okay? Times, here you have negative 3 differentiated to, okay, the first term is where all terms are expressed as an expression with exponent of 0. That's why all of them are equal to 1. But here, only k is raised to 0. So that will become 1, another raised to squared. Okay? Again here, k to the power 0, only k is raised to 0. That's why it is the only expression that will become 1. Negative 3 is still negative 3. Next, this is 1 here. So you will have negative 3 times 1 is negative 3 and then squared. So the answer for number 4 is just simply 9. This is with the use of the law of zero exponent, where we could just apply immediately that any expression or number or variable or term raised to the power of 0 will always be equal to 1. The longer method for this is if we are going to apply the power law. We're going to apply the power law to all terms. Let us see what will happen. For the first term, you will have negative 3. It's originally raised to the power of 1 times 0. And then you have k squared times 0. That's for the first group. Okay. Second, you will have here negative 3, originally to raise to the power of 1 times 2, because squared is what is shared. Again, with the use of power law. And you have k to the power of 0 times 2. This is for the second term. Then simplify them one by one. You have here negative 3 raised to 0, because 1 times 0 is 0. And then k raised to 0, since 2 times 0 is 0. For the next term, you have negative 3 raised to 2. Okay. But take note that if it's a negative number, make sure there is a parenthesis. Because if you're going to input, especially if you're using calculator, negative 3 without parenthesis and raise it to 2, the answer would be negative 9. Take note of that. Next here, you have k. 0 times 2 is also 0. Then it happens like this. Negative 3 raised to 0 is 1. Not negative 1, because again, it should be the whole. Sorry for that. It should be the whole. 1 times k to the power of 0 is 1, times negative 3 to the power of 2 is 9, times k to the power of 0 is also 1. So basically, the answer is still 1 times 1 times 9 times 1. You'll have here 9. So either of the two processes is correct. The first is automatically applying the law of negative exponent, or sorry, law of zero exponent. Or you could use the power law before you apply that law of negative zero exponent. You will still get the same result. My point here of sharing this is that when you try to raise a number, especially a negative number rather, to an exponent, make sure to enclose them in another parenthesis so that the negative sign will not be moved out or disregarded rather. Okay. So number 5, now for the last item for this short review. Okay. So we have this expression all to the power of negative 1. Now we do have the law of negative exponents. That's correct. But my suggestion here is for it to be easier, let us try first to use the power law. Okay? Because there might be some confusion as to the process that will be involved in simplifying this using the law of negative exponent. Why confusions? Because again, we are dealing with negatives. So might as well try to use the power law. In this case, we are going to share the exponent, not just here, not just there and there, but as well as the exponent of the denominator. So this is equal to, let me have it this way. Hopefully I could write it better. You have here w squared times negative 1. Only the exponent, power law. Okay. X negative 2 times negative 1. And then y, you have positive 2 times negative 1. All over w, originally 1 times negative 1. And then x, originally 1 times negative 1. And then you have y, originally 1 times negative 1. This is by the application of the power law, where we distributed the exponent of negative 1 to all terms inside the grouping symbol. Then simply get their values. You have here w, power of negative 2. Okay. And then you have here x to the power of positive 2, y to the power of negative 2, all over to w to the power of negative 1, x to the power of negative 1, and then y to the power of negative 1. Okay. From this, you could also apply the division law if you want to, since you have here pairs of expressions with the same basis. But then again, with the use of this negative exponent, some might be confused. So my suggestion is first to apply the law of negative exponents. The law of negative exponents tells us that if an expression with negative exponent, not the base, huh? The expression with a negative exponent may be transformed into a positive exponent by from a numerator placing the whole expression to the denominator, and from the denominator placing the whole expression to the numerator. My point is this. Let us use same color, sorry. The first term, W, you have your negative 2, so move it down. So you have here already positive 2, W squared. X will remain as there, X squared. Y, negative 2 will also be brought down here and become positive. As for the items in the denominator, supposedly W is here, but we need to move it up to make it positive, as well as X, as well as Y. Okay, I'm placing it here first. So this will be continued as, right? You will have this expression, sorry for that, you have X squared W X Y all over W squared and then Y squared. Now that all exponents are positive, this is the time that we could apply the other rules or laws of exponents. I'm talking about for X squared, since X is in the same uh, area, numerator, we're going to use the multiplication law. But for W and Y, being the variables are or the expressions are found in both numerator denominators, we will use the division law. So for X, you will have here X to the power of 2 plus, we have here 1, 1. For W, you have here again that interchange the exponents. You have originally here 1 minus 2. Because if you're going to make it 2 minus 1, that would mean that the exponent of the numerator is 2 and 1 for denominator. But it's the other way around. So you have here 1, sorry for that, 1 minus 2. Same thing with Y, 1 minus 2, as there is also 1 there. Simplify further, you have x cubed, and then you have y to the power of double power of negative 1, and then y to the power of negative 1. Further, we need to simplify it in such a way that all exponents are positive. Now, we could bring these two down and making a fractional expression equal to x cube is still in the numerator since the exponent is positive, and we'll have here w to the power of 1, y to the power of 1. Both exponents are positive, or you could write it without the exponent of 1, x cubed over w y. It is a longer process since we have applied many processes like number one, the power law, number two, the law of negative exponent, and then we have multiplication law, division law, and all the rest. Because we also again use here the law of negative exponent. As long as our goal is to simplify it, and this is the request of this practice exercise. So these are the answers for this practice exercise. You may want to review this from time to time and use this as you prepare for our assessments later on. So thank you very much for watching. Hopefully you have learned something or you have refreshed your knowledge on the laws of exponents, because we will use these concepts as we move on to the next video soon. Goodbye, everyone.